Hello, this is the second video in the Roots series for OCR Pure Core AS Further Maths and considers how to use the relationships between roots and coefficients. Here is a reminder of the outcomes that we found in session 1.1. For a general quadratic equation, ax squared plus bx plus c equals 0, with roots denoted by the Greek letters alpha and beta, we found that the sum of the roots, alpha plus beta, equals minus b over a, and the product of the roots, alpha beta, equals c over a. Here is an example of the type of question that might be asked. So here we're given an equation where a equals 3, b equals 2, and c equals minus 6. We're asked to find alpha plus beta and alpha beta. If we use that alpha plus beta equals minus b over a, then all we have to do is plug in the values of b and a in order to get minus 2 over 3. Alpha beta, which we know to be c over a, using those results from the previous slide, we know then is minus 6 over 3, or minus 2. I think it's quite useful to actually write down for yourselves what the coefficients a, b and c are, taking particular note of their signs before you do this type of question. Here is a reminder of the outcomes for cubic equations. So again, if we had ax cubed plus bx squared plus cx plus d equals 0, with roots denoted by alpha, beta and gamma. Here are the results for the sum, the pairwise and the product. So an example on a cubic equation. As you can see here, we have that a equals 2, b equals minus 1, c equals minus 2, and d equals 1. So if we're looking for that sum, alpha plus beta plus gamma, we know that that is minus b over a. So in that case that will be minus 1 over 2, which gives us 1 over 2. Note, but I'm being very careful and using brackets to make sure I get my signs right. If I look at the pairwise, alpha beta plus beta gamma plus gamma alpha, I know that that is c over a, which in this case is minus 2 over 2, which will be minus 1. And then the product, alpha beta gamma, will be minus d over a, which in this case will be minus 1 over 2, or minus a half. Here we are checking the results. Again, I would really recommend using brackets and being very careful with the signs. If for the same example you were then asked to find alpha squared plus beta squared plus gamma squared, you may want to pause to think about what the easiest way of doing this is for yourselves. There is a useful result that you can think of to work this out. If you think about squaring alpha plus beta plus gamma, you will, when you expand that, get alpha squared plus alpha beta plus alpha gamma, or gamma alpha, whichever way round you want to put it, plus beta alpha plus beta squared plus beta gamma, plus gamma alpha plus gamma beta or beta gamma plus gamma squared. As I said, it really doesn't matter which order you write some of those pairwise products in. Important thing to remember is that when you gather the terms up, you would end up with alpha squared plus beta squared plus gamma squared plus 2 lots of alpha beta plus beta gamma plus gamma alpha. Therefore, we can isolate this alpha squared plus beta squared plus gamma squared as being alpha plus beta plus gamma all squared minus 2 lots of these pairwise products. And that's a really useful result for us because we know what the values of alpha plus beta plus gamma and these pairwise products are. So from the previous slide, we know that this has a value of a half and that this has a value of -1, which gives us the result that alpha squared plus beta squared plus gamma squared equals 9/4. So whenever you're asked for something such as, alpha squared plus beta squared plus gamma squared, or for higher powers or lesser, it's worth remembering this sort of, if you like, trick of squaring something you do know and extracting the bits you don't. In the next session, 1.3, we will cover forming equations with related roots.